Welcome to the deep dive. Today, we're giving you the ultimate shortcut to understanding a mathematical victory that was, well, thousands of years in the making.
And the incredible part is, it wasn't achieved by some tenured professor at a university.
No, not at all. It
Uh-huh.
was done by a couple of high school students in Okinawa. Okay, let's unpack this. We are talking about the Pythagorean theorem. Everyone knows it. 2 plus b2 equals c22.
It's ancient, it's foundational. I mean, there are literally hundreds, maybe thousands of proofs for it. Geometric ones, algebraic ones.
Right. But there has always been this one great paradox, a challenge, trying to prove it using trigonometry.
Specifically trying to prove it with trig without cheating, without using circular reasoning.
Exactly. And that's where our source material comes in today. We're looking at the work of two high school students from the Okinawa Math Academy. They published a paper called Trigonometric Ratios Can Prove the Pythagorean Theorem.
And not just anywhere. In the international journal Parabola, which is issued by UNSW Sydney, plus it's on the ArtSIF preprint server. This is legitimate.
It is. So our mission today is really twofold. First, we need to get into the weeds of this non-circularity problem, what makes it so hard. And second, we have to explore what this means for math education, everywhere.
It's fascinating because what this really gets at is the purity of a mathematical proof. With $T plus B2 equals CD2, you have this incredibly solid foundation.
Right.
Any proof that just rearranges shapes or uses basic algebra it's clean. It's accepted.
But the moment you bring in trigonometry, things get messy.
They get very messy, which is so counterintuitive, isn't it? I mean, trigonometry is literally the study of the ratios of sides in a right triangle. It should be the perfect tool.
So why is it the biggest trap? Why has this been deemed nearly impossible for so long?
It all boils down to your starting point, your axioms. Think about the most fundamental trig identity there is, the one everyone learns.
Sine squared plus cosine squared equals 1.
Exactly. Sine to theta plus cotheta equals 1. The question is, where does that rule come from?
Uh-oh. I have a feeling I know where this is going.
Yeah. In almost every textbook, in every standard curriculum, that identity is proven using the Pythagorean theorem.
Ah.
You define sine as opposite over hypotenuse, cosine is adjacent over hypotenuse, and then you plug those into $A plus B2 equals C22. And plop, out comes m theta plus cos 2 theta equals 1, 1.
So if you turn around and use that identity to prove the theorem,
Yeah.
you've just run in a perfect circle. You've used the answer to get the answer.
You have. It's like,
Ah.
imagine a legal case where you use evidence that could only have been created if you already assumed the defendant was guilty. It just doesn't hold up. In a formal proof, that's a fatal flaw.
So to do it right, you'd have to build up your trig identities from scratch, from pure geometry,
Yeah.
without ever touching the thing you're trying to prove.
That's the challenge.